to see you.
Nice to see you.
Oh, this place is awesome. So, how did I get the name Gentle Giant?
Well, Gentle Giant. The owner of the company, Carl Meyer, is a really big guy. He said gentle nature. A lot of his friends called him the Gentle Giant, so the name just kind of seemed to fit.
Huh, well, that's cool. And originally it was a toy company, right?
Toy prototyping, yeah. In fact, we still are a toy prototyping company. We make toys for other people that develop toys and collectibles, and we have our own line of toys and collectibles.
Okay, but you also do some work for film, right?
We absolutely do, yeah. Way back when, we actually adopted 3D scanning technology to scan maquettes, and that would segue right into product development, and we realized that could open up to VFX and some of the film needs they have in production. It would segue into that. But why don't we take a look around?
Yeah, that'd be great.
Okay.
So how does this process, where does it start from? What do you do to begin with to get something like this?
Well, like I said, we take the original sculpt that we make, the prototype, and then we'll digitize that. And once we have that data, we've cleaned that up, we've made sure that it's all hole filled, it's a watertight model. We send that on to CNC foam milling, which essentially takes a huge chunk of foam and it just mills it out. It creates a tool path based upon the scan data. And then from there, we take that and we will cover it with clay and go right in there and do all the smaller details. We'll reintroduce all those details from the original sculpt. And then we'll coat it with a resin, paint it, and this is what you see. It's the end result.
Awesome.
Here's another example of a life-size piece.
Wow.
Yeah, that's Cuso from Red Star.
Yeah.
And Chris Gossett, actually, who has worked with us over the years as one of our 2D artists, and we've had a lot of collaborative projects. This is one of the featured characters in that comic book. So we had to, after we made a limited run mini bust, resin mini bust, we decided to scan that and go into this scale for Comic-Con.
That's amazing. So cool.
Cool, thanks. So now we're into the digital department, and we have a lot of our head scanners, body scanners staged here, where we can take everything out on location, scan the actors at their home or on sets, and in some cases we have to break down all that equipment and ship it around the world to get it to set.
Right.
So.
Okay, so why the trailer?
Well, actually, we need to be mobile with our scanning equipment. The actors' schedules are so tight, they can't always make it to us. We need to go to them, and that puts us ahead of everyone else doing this. So what we've done is we have a custom trailer built here that you see with a full body scanner and head scanner housed within, and that lets us go to sets, studios locally, and you know, we should take a look inside so you can get a look for yourself, okay? So what we have in here is the body scanner. Actually, it's a cyberware body scanner, and we're able to go to set and work around the actor's schedule, the shoot schedule, and they'll come in here between takes and get a quick 20-second body scan, which delivers 500,000 to 1 million polygons in a random ordered mesh.
Oh, wow.
And it's just really high detailed scan.
And how long does it take, you know, for it to get a scan?
Each scan is 20 seconds, but we usually have about half an hour to an hour with the actors because the head scanner, that process takes a little bit longer. You know, we have to get them to emote and, you know, get those expressions that we need.
Wow, so they just stand right here and then the cameras go around?
Absolutely. Well, actually what happens is the actor will stand up here like this, and the scan heads will actually come down. They travel one direction down. Once they've actually hit the floor there, that we're done, they come back up. We have 4 cameras. There's 1 camera in each one of these heads, and that projects out a near-infrared laser, and the cameras record the topology based upon where that laser falls on the subject.
Oh, okay, awesome. So what are some movies that have been created with this device?
Somewhat recently, Pirates of the Caribbean. Actually, all of the films there. We were out at Universal Studios on set, and we had Johnny Depp and Keira Knightley and many others from the crew, the cast of that. And we scanned them for various VFX houses.
Huh, that's awesome.
Now next, I would like to show you where we go from digital to practical.
Okay.
And that is all about the rapid prototyping technology that we incorporated into our process. Go through here.
Oh wow, so this is where it actually gets built, huh?
This is our rapid prototyping machine. This is one of them, I should say, out of 6. This is the newest addition to the RP family here, and this is actually the Eden machine. And what it does is it takes that digital model and it slices it up into very, very thin layers. The software does that, and basically gives this machine a tool pattern to go from. And it works a lot like a 2D printer, only in this case, we're laying down resin.
Huh.
That's kind of how it works.
Wow. So it's actually, it's like a waxy resin type substance that it creates it in?
Exactly. There's 2 parts to the process. There's the build material and the support material. And the build material is kind of a polymer. It's a UV catalyzed polymer. So when you look at it, you can actually see the light there. It takes a pass over the subject matter and it solidifies it. So every 15 micron layer thickness, or thousandths of an inch layer thickness, gets catalyzed, and that's the platform drops down just enough to accommodate the next layer.
So how long does it take to print something like this out?
This one will probably take about 6 to 7 hours. It really depends on how much resolution we're trying to get out of the subject matter. The better the resolution, the longer it takes.
And for a machine this size, how big of a model can you make, a sculpture?
Actually, this is a pretty large footprint that this machine has, so you could build about 12 inches tall and almost 12 inches wide, really, as well. So you can get a sizable amount. If you have a really large sculpt that you want to do, a really large prototype, you could cut that data into sections and then glue it together after the fact.
Okay. So do you have any samples of some of the printouts the machine like this has made?
Absolutely. Let me show you one of the our more prized sculpts here that we've done.
Oh, wow.
This is the actual a Venom from Spider-Man. And if you take a look at this, you can see all of the mesh details that came out so crisp and clean. It would almost be impossible to do via traditional sculpting.
Yeah.
So everything you see here was a result of a ZBrush model that was done by one of our premier artists here. And that data went right to that machine, the Eden, and then that built that up very slowly at very, very thin layers. And what we end up with is a final sculpt that we really don't have to go back into traditional sculpting with.
Yeah.
We go right to manufacturing, right to the master mold, and then we do our limited run collectible resin piece.
That's amazing. And that takes about 6 to 7 hours.
Actually, this one was probably more like a 20-hour build.
Oh, really?
But
okay.
You weigh that out against a week of sculpting.
Yeah.
It really works out.
Can I hold it?
Absolutely.
afraid I'll drop it.
So in here we have our 2D concept department, and they do a myriad of things, really. Part of what they're tasked with is coming up with product ideas and or really illustrating some existing ideas that our product development department has. Then we hand that over to the sculptor as an approved concept design, and from there we start to sculpt and bring this into 3D.
So mostly your 2D artists work as inspiration for your 3D sculptors, is that right?
Exactly, but that's only part of the picture. Really, we also task these guys with doing character concept work for video games, sometimes feature film as well. Video games is really, that's a big industry for us, especially with the concepting side of things. So we'll get a couple of lines sometimes, really a character description in a character document, and we go from there and we'll do our thumbnail sketches, we'll go to tight lines, sometimes we'll do mood paintings or speed paintings on the characters that are approved by the developer or the client.
And so that kind of stuff never becomes a sculpture, but you're just doing pure conceptual artwork for some of these video game companies.
Exactly. That concept work goes right into our ZBrush pipeline and our Maya pipeline to create the digital assets that are dropped right into the game.
Wow.
We'll do the textures and make sure that everything that we're creating is within the parameters of their pipeline and is usable for in-game use.
That's so cool. So for my helicopter that I modeled for this behind-the-scenes project, how
Right.
does that fit into this whole process here?
Well, you know what? We'll take you back to the beginning of that process. In order to do that, we should talk to Scott Spencer. Let's
Okay,
go meet
great.
him. Okay.
All right.
Hey man, how you doing?
Hey, how's it going, Scott?
Good to see you again.
So how does the helicopter I modeled fit into this process you guys are doing here?
Well, once we got the geometry from you, we take that my ASCII file, open it up, and just make sure that all the polygon surfaces are either watertight or intersecting the base geometry.
What do you mean by watertight?
Well, we want to have one contiguous surface. For instance, if you've got a sphere and then a box, you don't want that box sitting on the surface of the sphere. You want them to be intersecting, so when the machine builds, it's got one surface, one part that it can put together. So I've actually got an example here that I can show you. This is a governor motor, and this is a 3D model.
Wow.
But what happened is, because these parts were modeled to move, they'll rotate around each other.
That's amazing.
So the idea is, because there was draft and empty space in between all these parts, they'll actually function. So with the helicopter, we want to make sure that all the greeble surface and the detail, all the little technical elements, actually are grabbing onto that surface, so when it's built on the machine, it'll actually build and be part of it, as opposed to just sitting on the surface, in which case it would just fall right off.
Right.
So once we've got that done, once we have that processed, then I'll take the model, make sure that it's within an acceptable polygon limit. If it's not, then I'll just take some pieces and decimate them slightly.
And what is an acceptable polygon limit for what you're doing?
Typically around 300 meg.
Huh.
So once we're within that limit, I'll go ahead and send it over to the output machine, where it's extruded layer by layer until 24 hours later, where we've got the final part.
Okay, so now that Scott has explained to you how he got it from the digital model to the practical model, we should go check out the final result.
Great,
Okay,
let's do it.
take a look. Here we go.
Wow, look at all this.
This is it.
Wow, wow, look at that thing.
Isn't that cool?
That is awesome.
So you can see all that detail that you put in the original digital model, and now you have a practical maquette.
Yeah, look at all the detail the printer is able to capture.
Pretty cool.
That's awesome.
Even the thin blades up here. And
Now, did you have to print those propellers out separately? Or?
absolutely, there was some fabrication after we had the printed
Okay.
out parts, and some assembly required, so to speak.
Yeah. Wow, that's fantastic. Hey, Brian, thank you so much. For all the work.
Absolutely, you bet.
And thank
More
you so
than
much
welcome.
for the tour. This place is amazing.
Oh, thanks so much. Well, hope you enjoy that model.
Oh, this
That's
is great.
a lot of hard work on your part, and I think it came out fantastic. So
Yeah, so do I.
here we go. Enjoy.
Great. Thank you so much.
All right.
We'll see you.
Take care. See you.